Now I am going to explain about discrete Fourier transforms. So discrete Fourier transform is nothing but it is a sequence of periodic, and we have to it is used to convert from time domain to frequency domain. So here the Fourier transform of a signal x of n, which is defined as x of k is equal to summation n is equal to 0 to n minus 1 x of n e power minus j omega n. Now, if you take omega is equal to 2 pi kn by n. Okay, so now if you substitute omega is equal to 2 pi kn by n, then n is equal to 0 to n minus 1 x of n e power minus j 2 pi kn by n. So this is x of k. So this is discrete Fourier transform. Okay. So now the inverse discrete Fourier transform, which is defined as x of n is equal to 1 by n summation k is equal to 0 to n minus 1 x of k e power j 2 pi kn by n. So this is inverse discrete Fourier transform. The definition of DFT and inverse DFT. Okay. So now coming to Twiddle Factor. So this DFT can be based on Twiddle Factor, using Twiddle Factor. So that is nothing but DFT using Twiddle Factor. So Twiddle Factor is nothing but, so Twiddle Factor, so this is Twiddle Factor which is represented as W suffix n. So Twiddle Factor is nothing but W suffix n, which is equal to e power minus j 2 pi by n. So that is DFT. Twiddle Factor. So now DFT using Twiddle Factor. So DFT using Twiddle Factor means, so as we already know the formula of discrete Fourier transform, that is what, x of k is equal to summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi kn by n. So this is the formula for discrete Fourier transform. So now in place of e power minus j 2 pi kn, so this can be written as W suffix capital N into nk. That is nothing but x of k is equal to summation n is equal to 0 to n minus 1 x of n W n nk. So this is the formula for discrete Fourier transform using Twiddle Factor. Okay. So now how to calculate Twiddle Factor? So Twiddle Factor can be calculated as so Twiddle Factor which is calculated as, so what is the formula for Twiddle Factor? Wn is equal to e power j 2 pi n by n. Okay. So 2 pi by n. So if you write it as 2 pi by n. Okay. So e power j 2 pi by n is equal to what? Cos 2 pi by n minus j sin 2 pi by n. Okay. For example, if you take let capital N is equal to 8. Okay. So for n is equal to 8, what is the twiddle factor? W suffix 8 is equal to what? E power minus j 2 pi by 8, which is equal to cos 2 pi by 8 minus j sine 2 pi by 8. Okay. So cos pi by 4 minus j sine pi by 4. Okay. J sine pi by 4. Okay. So now cos pi by 4 value is what? 1 by root 2 minus j into 1 by root 2. That means, so here the suffix is 1. That means W8 into 1. Okay. So if you take it here as small n into k. So here you can get small n into k. So n k is equal to 0, 1 and so on up to n minus 1. Okay. So now this is the value of W8 suffix 1. Now in the same way, if you calculate W8 0 value, that means what? The suffix n into nk, which is nothing but here n small n into k is equal to 0. W8 into 0, which is equal to e power j 2 pi e power j 2 pi. Okay. So e power j into 0 divided by n. Okay. So e power j into divided by n, which is equal to what? 0. Sorry, e power 0 value is what? 1. So W8 0 value is 1. So in the same way, W8 suffix 1. So W8 value is what? 1 by root 2 minus j by root 2. Okay. So W8 2. W8 2 value is what? So W8 2 value is minus j. So you have to calculate in place of nk and n, substitute values. N is equal to 8. For that you are getting W8 2 value as minus j. In the same way, W8 3 value. So W8 3 value is minus 1 by root 2 minus j by root 2. Okay. So now, okay. So W8 4 value is what? So you have to calculate, you have to substitute. N is equal to 8 and nk is equal to 4. So you are getting W8 40 value is 1. So these values are very important for finding algorithms, fast Fourier transform algorithms. So you have to remember W8 0 value is 1 and W8 1 value is 1 by root 2 minus j by root 2 and W8 2 is minus j. W8 0 value is minus 1 by root 2 minus j by root 2 and W4 is